So let's start. Welcome you guys to the Crack the Placements channel. So now so today we are going to learn the Inorder traversal. That is, I am going to teach all the kind of traversal, that is the recursive way, iterative way and the Morris traversal way of this Inorder traversal. The recursive way is the most simplest way in order to do the Inorder traversal. I'm solving in lead code, and in this lead code so we are having the 94th question as binary tree in order traversal. So here the question says they have given the root of the binary tree, that means they have given the reference to this one, and we have to return the in-order traversal of its node values. That means so they'll give the reference to this node 1 and we have to return the vector which is nothing but the in-order traversal of the tree. So here they have given 1 null, 2 and 3. So that means 1 is the parent node and its left child is null and its right child is 2 and the left child of the 2 is 3. So this is the empty set, and so this is the 1. So they have given that recursive solution is trivial. That means the recursive solution is quite easy and they are asking us to do iteratively. So first I am going to tell the recursive solution of this one. So first let us understand what is meant by in-order traversal. So now let us consider a tree which consists of the elements 1, 2. I am just considering a random tree here. So 4 and 5, and also I am going to say you the trick at the last. If you want to know the trick of that particular video, comment in the comment section. So first thing, the basic funda behind the in-order traversal is that first we are going to visit the left child and then we'll move on to the parent, and after that we'll move on to the right child. This is the basic formula or the funda behind this in-order traversal technique. So here it is saying that first we have to go to the leftmost node. So that means here the parent is present, and first I am going to visit this left child, and I am going to visit the left child of 2. So that means we are going to start the in-order traversal from here. That means what we have to do, we have to reach the leftmost node present in the tree, and after that first the left child, that means we have to print 4 here, and after that 4 has been completed, and then we have to move to 2, that means the parent of this thing. So hence I have to print the 2 here, that means left child, parent, and after this one I have to move to the right child. So hence this is 5. So if we see as a whole, this is the parent, 1 is the parent, and this entire thing is the left child, and this entire thing is the right child. So first what we have to do, we have to process this left subtree, and then we have to print the parent, and then we have to move to the right subtree. And in this one, I initially I was in the parent 1, and after that I come to 2, and in this particular subtree, so I have to access the leftmost child first. So hence I have accessed this 4, and after that the parent, and after that the right child 5 has been printed, and after that the left part is cleared. Now we will print the right part, that is 1, and after that we will come to this right subtree, and in this right subtree we will move to the leftmost node, and that is 6, and after that we will move to the parent, that is 3, and after that we will move to 7. So this is the way in which we have printed the in-order traversal, and this is the basic intuition behind that. That means first we should visit the leftmost node, and after that its parent, and after that its right child, and after processing the thing, after processing the left subtree, we'll move on to the parent, and after that so we'll move on to the right subtree. So now let us see the recursive solution. So this is the recursive solution. So first, in order to store the vector, that means we have to create a vector which consists of the Inorder traversal, right? So I have created Inorder globally. So because in this recursive call, this Inorder must be updated frequently, so that if we define this Inorder inside this function, then after each recursive call, this Inorder is going to set to null. That means the empty vector in each and every recursive call. So in order to avoid that, so we have declared that particular Inorder vector outside this function. So first, so in any recursive call there are so three things. One is the base condition. So one is the base condition, and the second one is the hypothesis, and the third one is the induction step. The base condition is that suppose if the root is equivalent to null, that means so we have given an empty tree. That means the second example saying that they have given an empty tree. So in that case, what we have to return? We have to return an empty vector. So in order to return that, so the basic easiest thing is that we can use this curly braces. It indicates that it is an empty vector, and we are returning the empty vector when the root is null. And after that, let's come to the hypothesis. In this so hypothesis part, so what we are going to do, so we are just so traversing the left and the right subtree. So that means we are going to make the recursive call. So I'll copy this. So we'll just make the recursive call and traverse the complete left subtree and the complete right subtree, as I have said. So first we have to traverse the left subtree, and then the parent node, and then the right subtree. So first so let us traverse the left subtree. So roots left, so we have traversed the left subtree, and in the middle so I have to do something which is related to the parent. So here in this parent part, I am just going to push that particular vector, so push that element, that is so I am going to push something. So I am going to use the emplace back function. So if you know the vector, so it is quite easy. If you don't know, so comment in the comment section. I am going to make a series on the vector also. So Inorder dot emplace back, so this function is going to roots val. So here in this particular tree node, they have given that so here val is the function which is going to hold the value of that node, and I am going to push this roots val into the vector. So it is similar to the pushback, but emplace back is considered to be more efficient when compared to this one. And after doing this, so Inorder traversal, so Inorder traversal, and here I am going to traverse the right subtree. So first one, I have traversed the left subtree, and in this parent section I have pushed the element into this Inorder vector, and after that I have traversed the right subtree. And after doing this in the induction step, so we should so just return the root here, not root, it is the Inorder vector. We have to return the Inorder vector. So in the induction step we usually perform some kind of operations, but here as we have to just move the roots value, that means we should just return this Inorder vector. So it is not necessary that we have to return this we have to perform any kind of operation in this induction step so that we will get the answer. So it is very simple. If it is root, I am going to return the empty vector, or else I am going to traverse the left subtree, and then the right, and then I am going to insert the element into the Inorder vector, and after that I am going to traverse the right subtree, and after that I am going to return this so Inorder. So first I think it is going to work, but let us see. So I am going to run the code. It is working, and so in lead code we have to check all the test cases, and after passing all the test cases, then only we have to come to the conclusion that our code is working. So or else don't blindly believe after passing one test case that you have cleared all the things, so and hence null. So this is my test case, okay, so in which I have given the values in a random manner. And now let us run the code. Suppose if this works, then our code is 100% correct. Yeah, it is working fine. Now I'm going to submit the code here. Yeah, it's working fine. So as it is a recursive thing, so and one more, the time complexity, about the time complexity. So here we are going to visit each and every node at most okay, twice, okay, so hence the time complexity will be O of n, and the space complexity, if we consider the built-in in-order stack, then the space complexity is also going to be O of n. So this is about the recursive in-order traversal. Thank you.